Hello, welcome back to Cracking the Cryptic, and a puzzle by Donatello86, who has featured on the channel before, and obviously loves pizzas and hanging out in sewers. Now, this puzzle features some unusual German whispers, I think, and we'll explain those in a moment, as well as trying to pronounce the puzzle title, which the constructor has told us he doesn't know how to pronounce. So we'll have a go at that. Don't forget, on Patreon, the 1st of November, the launch of Duality 2, the brilliant puzzle pack by the Skunk Works. Give it a try. It's going to be epic. There's all sorts of other stuff on Patreon. Connections videos every 4, 5 or 6 days. Crossword videos. And lots more Sudoku packs and things. The Duality 1 pack was released free in the middle of October, so very well worth your time and attention, Patreon. And of course, the apps are very well worth your time, attention, and money as well. They are fantastic apps full of brilliant puzzles. What else have we got? We've got all of our merchandise and Sven's Sudoku pad on the links under the video. Do check them out, but the first link is to this puzzle. I'm going to call it German in Deutsches because the EU, I feel, has to be pronounced in the manner that a German would. Even though I'm not then giving a Germanic pronunciation to the X, I am going to give that vowel, that diphthong in the middle as oi in Deutsches, because I think that's how a German pronounces EU. And as I say, the constructor gave us no guide as to how to pronounce this, and I don't know why it's got that title. Anyway, what I'm going to do is read the puzzles. Read the rules. Normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3 by 3 box. Cells separated by an X sum to 10. Cells separated by a white dot, I think there's only one of those, are consecutive. Digits in cages sum to the value given, so those 3 add up to 14, and there are no repeats in the cages. Digits on an arrow sum to the attached bulb, that meaning that that cell is equal to that cell in this puzzle. Now, adjacent digits along a green line have a minimum difference of 5. That's the normal German whispers rule. You could put 1 and 6 here, or 4 and 9, but not 3 and 7. Minimum difference of 5, so you could actually put 1 and 9 there. Each green line references one other green line of the same length. Position X of both green lines sum to 10. Position 1 of a green line starts at the attached green circle, and the position increases along the line. E.g., imagine, well, he's given an example of a 5-cell line. Let's use the first 4 cells and say that this was 6, 1, 8, 2. If that then matched with this line, this would go 4, 9, 2, 8. So that each position along it added to 10 between the 2 lines. That's really strange, but it is obviously going to maintain the differences the same on both lines. So that's how these lines are indexing to each other in a very weird way. Never seen a rule like this before. Don't know how long this puzzle's going to take. Gonna start it now. Let's get cracking. So, we've got a 10 cage here. So these 2 cells on this green line are at least 1 and 6. They add up to at least 7. The most this can add up to is 3. And it is therefore low. And I think we are going to be colouring this puzzle between low and high. Digits on a green line alternate between high and low. Because, I was going to say because they have to, but 5 can never appear on a green line because there are no possible neighbours. You can't have 2 digits lower than 5 next to each other, or the difference wouldn't be enough. So the line numbers alternate low, high, low, high. Also, we have to be careful. 4 and 6 can't get placed in a position on a line where their neighbours could see each other. If you tried to put a 4 here, for instance, those would both have to be 9, but they're in the same column, and that breaks Sudoku rules. So this is 1, 2, or 3. This one is also 1, 2, or 3 for a different reason, because this pair had to add up to at least 7. You notice I haven't been able to colour those blue and orange. I don't know which way round those go. I'm using blue for low, orange for high. This one could be a 9 or a 6 because it's not constrained by anything really. This, oh, and of course an X is always going to have one blue and one orange digit on it because that's how you add up to 10 with something lower than 5 and something higher. Now, yes, I get that. In this line, in this row, there's one blue and one orange here, but double orange here. That's 3 oranges already used. These two, because we alternate along the lines, are going to be the same colour, so they have to be low. And that's really interesting because they're now high, and this line does not index to this line, because when the two lines index to each other, and the first 2 cells, for instance, add up to 10, one of them is going to be high and one is going to be low. So the lines that index with each other are going to have opposite polarities as you go up the line. So these ones don't index to each other. And there are 2 other 4 lines, and now these 2 other 4 lines must both begin orange and then alternate all the way along themselves. So we actually get quite a bit of a start there. In colouring the grid we do. Now in this row, oh, there's got to be a 5 in this row, and now I know where it goes. And this one I can colour because that's going to be one orange and one blue. This must be blue and that must be orange. And this is going to be a puzzle of parity colouring the whole grid, I now believe. Ah, look, I can colour this cell because I've got 2 blues and an orange here. The 5 in this box can't go on an X or a green line, so it's in one of those cells. And the other 2 digits in this 15 cage, which is a very carefully chosen number, add up to 10. So they're 1 blue and 1 orange, just as those 2 add up to 10 and are 1 blue and 1 orange. And that's going to use up 4 blues and 3 oranges and make this orange. And the other cells on this alternating 3-cell line are blue. Now, I think in this puzzle, there are exactly 4 4-cell lines, 4 3-cell lines, and 4 2-cell lines. And we've already got a lot of information. Well, we've got all the information about the 4-cell lines in terms of alternating their polarities. We begin now with the 3-cell lines. We've got one that goes blue, orange, blue. Oh, the 5 in row 2 has been writable in from the start. It's the only non-green cell in the row. That was the easiest digit in the puzzle, and here I am eventually getting to it. Oh, and these, right, that's a pair of blue-orange, that's a pair of blue-orange, there's a blue. We need 1 blue and 2 oranges on this line, and we know which way round they go. Blue there and orange, orange there. Now, that line could index to that line, but it doesn't have to, because there are 2 other 3-cell green lines still to colour. Is that the right term? Now, this is high on the 14 cage, so it's at least 6. These add up to 8, or somewhere between 5 and 8, so they could be both low. These are the same colour. No, I don't quite know where we are now. This box has had 3 blues. Oh, we've had 3 oranges in this row. No, I don't know. I want to find somewhere where we've used up all the oranges or all the blues. That is a pair, one of each. The 5 in this row is going in one of those cells, and the remaining 2 cells are one of each. That's not helpful. Right, what is going on? Maybe I need to do some numbering or think about the indexing. I just don't have much going on with the numbers yet. Probably want to use the 10 cage and the 14 cage once I've done more colouring to determine numbers, I feel. I mean, all I can say is whichever line this maps to, which could be that one or that one, both of its orange digits are going to be from 7, 8, 9. It's not really the kind of... I mean, I suppose this is always going to be from 7, 8, 9 because its neighbours see each other. That's always going to be from 1, 2, 3. This one's always 1, 2, 3. Oh, I mean, that is interesting because both position 2s that are blue on 4-cell lines are 1, 2 or 3. And that means both position 2s on 4-cell lines that are orange are 7, 8 or 9. So I have ruled out 6 from there in the end. I mean, it's not strong stuff, is it? But it is stuff. That is 7, 8 or 9 because of the X. So we're going to have to find... This is 7, 8 or 9 as well because these two see each other. We're going to have to find somewhere where 6 does go. Or can go in a box or a region or a row or a line where nothing else can be a 6. That's probably what we're going to have to do. Or a 1 or a... Sorry, 6 or a 4. And then that's actually going to give us real information. But the trouble is, X could eat up the 6 and the 4 in either case, or even both of those cases in columns 1 and 2, and I'd be none the wiser. This line goes... Okay, I don't know which way it goes, but let's colour it red and yellow, because that is the same as this. That is what the meaning of the arrow is. So now in this row, we're going to get a red and a yellow there. So that's one of each, that's one of each, that's one of each. That is not 5. So 5 is going in here. And now the other 2 digits in this, well, the other remaining digit is low in this bottom section because that's high. We've got a maximum of 8 in those 2 cells. So the other digit is low and is indeed not 4. But the point is, that is low, this is one of each, and this one must be high. Now I can alternate this line, and now the 2 blue, orange, blue lines are there and there. The other 2 3-cell lines are orange, blue, orange. We've got one there, and this one is orange, blue, orange. So that converts my red and yellow into orange and blue. Okay, that's neat. This is now, the remaining cells in this box are 1 blue and 1 orange. And in this row we have 5 and 1 blue. Oh, 5 is looking at that digit, which is therefore not 5 and is blue, and this digit is not blue and is 5. And now 5's in one of those cells. 5, that's not 5. This is 5 in the bottom row because there's a 5 in one of those. 5 in one of those 2 cells. I should have focused a bit earlier on 5s, clearly. Now, okay, how about these 2 in the 14 cage? This one I was claiming couldn't be a 4 because that would only be 5. That's true. That's 1, 2, or 3. This one can't be a 9. So that's 8, 7, or 6. Now, if I knew which orange, blue line this one mapped to, I could then paint the finish of it as 2, 3, or 4, which is either there or there, and I can't, because I don't know. So that mapping is going to definitely be a part of this puzzle at some point, but we're still making progress on colouring. So I've coloured all the 3-cell lines, mind you. Now the 2-cell lines, I've got one here that goes orange-blue. I've got this one, about which I have very little idea at the moment. And this one and this one. The only thing I know about this line is the most it can add up to is 9, so it doesn't have an actual 9 on it. Yeah, it doesn't seem very helpful, does it? These 2 are the same digit. I keep on wanting to read these lines as thermos. That is totally irrelevant. The circles are just to determine which is the beginning of the line. So I have to try and get that out of my head. Now, I haven't really matched up lines very successfully at all. But then I haven't really tried. I don't know. For that to be a 7, this would be a 1-2 pair. Then that would be 3 and this would be 7. Yeah, I've probably got, oh, that is 1, 2 or 3 because its neighbours see each other. Where's the other? Right, so the third position on the 4-cell lines when they're blue is always 1, 2 or 3. Well, they have to be matched by a third position on the orange that is 7, 8 or 9. I mean, it's hard to see that this is valuable yet, but it might be. It might be. It's going to be something about 4s and 6s and their possible positions. I don't know how to work that one out. Okay, possible positions for 6 in box. Right, this can't be a 4, I've just worked out, from this box. Because 6 is either in the 15 cage with a 5 and therefore with a 4, or on the X, therefore with a 4. So wherever 6 is, it's bringing the 4 with it, and 4 is not here. So the end of this line is 1, 2 or 3. Now, where's the other 4-cell line ending in blue? There. If I could prove that one of these was a 6, I would know that was a 4. And that would feel like, I have a feeling it could be a long time before I get a digit other than 5 in this puzzle. A whole digit. And that might be a breakthrough to let me do that. If I could just work out how on earth it worked. No, I don't know. 5 in the central column is done. So one of those remaining cells is blue and one is orange. This one is blue or orange and it's opposite. Oh, we've had 3 blues in column 7. 3 is not... 4 is a much better number than 3 in that respect, unfortunately. A much better number. Not close, just much different. Okay, the white dot here. I mean, this can still be 6. But it's very forcing of everything else. Oh, it can't be 6. Because that would be 1 on the whisper, and this would be 9, and that would break the white dot. So this is 7, 8, or 9 as well. That's 1, 2, 3 as well. This is the 4th position on a blue, orange, blue. Well, that's different from the 4th position on the other blue, orange line. And one of those two is definitely an 8 in this row because of the white dot. Therefore, one of these two is definitely a 2. And what does that mean? That means that one of the position 3s on the orange, blue is an 8. One of these two is definitely an 8. Is that a useful thing to find? Hard to say. And not correct either. The fact that one of those two is a 2 does not mean that one of those two is an 8, because those two are not the 2 positions for the 3rd cell. So I'm sorry, that wasn't accurate. One of these, though, is an 8. This is 6, 7, or 9, because it can't be an 8. 6 could be there, but then 4, well, then that would be 1. This is not a 2, because 2 is definitely one of these cells in the box. So that is 1, 3, or 4. And that's a 3-cell line mapping to either there or there to give a 6, 7 or 9. I'm just not getting at the information I need here. I'm not really getting close to it. This is weird. What on earth am I meant to be thinking about that is so difficult at this point? I suppose if that was a 3, this would be an 8-9 pair. Is that interesting? Almost. If that was a 3, this has to be 8 because that has become 7. Yeah, this little triangle is one of the most interesting triangles around. 2, 8, anything. 1, 9, 8. 3, 7, 8. I don't know. That didn't really limit anything in the end. Wow, this is hard to think through. So this is a 3-cell line ending in blue. That's matching the 3-cell lines ending in orange. This is the same digit. Is that interesting? One of these is orange. That's not interesting. One of these is blue and one is orange. I don't know. These two add up to 9, but one of them is the last cell on a 4-cell line mapping to there or there. Goodness gracious, I don't know what's going on here. I don't understand how to do this. Okay. In this row, there's an X pair there. And so these 3 must be the X pairs of these 3, because obviously you can pair up all non-5 digits into 4 X pairs. So that's one of the X pairs. These 3 are the X pairs of these 3, which definitely include 8. So one of these is a 2. And for one of these to be a 4, one of those two would have to be a 9. That would make that a 6 and that a 1. Otherwise, if that's not a 6, this is a 4-6 pair in this row. And then that would be a 7, 8, 9 pair. This would be a 1, 2, 3 pair. I don't know what that does. It doesn't seem... I'm really just speculatively looking around trying to find things that might influence how I tackle the puzzle, and I'm really struggling to find any. Oh, goodness gracious. Okay, if that was a 7, this would be a 1, 2 pair. The central digits of the 3-cell lines that have orange in the middle are different from each other because they're in the same row. So the central digits of the 3-cell lines which have blue in the middle, oh, look at that, they're in the same column. That turns out to be rather uninspiring then. This is fiendishly tough. Here's a thought. This digit in box 8 is in one of those 2 cells because it can't be there because that's the same as this. So then it's in one of those 2 in box 5. I mean, it's a very minor thought, but you never know. One of these thoughts is going to pay dividends at some point. Okay, how about this pair, which definitely add up to no more than 9. Now that means there's some counterpart pair, which could be there, that add up to at least 11. That's just not interesting information. Oh, there's something. Oh, this is 7, 8, or 9 because its neighbours see each other. Right, and both of these are different and from 7, 8, 9. So this is from 1, 2, 3. And where's the other blue in the middle of 3? There. That is 1, 2, 3 or as well because both of those are from 7, 8, 9. Okay. Now, the 4 in this row is either there, making that a 9, or here, making this a 4, 6 pair. I don't know. I mean, it's the tiniest little advances at any point in this. I'm really not confident with how this is going. This obviously can't be an 8 in this box, and that's 6, 7, or 9, and the same's true there. The trouble is it can be 6. That would make this a 1. The reason I'm interested in this possibly being 6 is if not, that's a 6, 4 pair. So can this be 4? That would be 9. This would be 7 or 8. Four there would make this 9. This would be 6 or 7, so that would have to be 1 or 2. Oh, there is some tipping point here where if I can just find something, I'll be able to flow it through using the whispers. Where is that tipping point and why can't I see it? It's going to be about 6s. I feel it's going to be about 6s. Well, there is a 6 in one of those 3 cells in this row. Just facts. There is a 6, yes, in this row. There is a 6 on a line somewhere, isn't there? So that can never be 1 because the 6 is touching a blue digit on its line in that row. So that can never be 1. Now, does that do anything at all? It means that one of these orange starters on a 4 can't be 6. No, can't be 9. It means one of them can't be 9. Okay, let's think about this row a bit more because, again, there is a 4 somewhere on it, on one of these two, taking the 9 with it. Somewhere in these cells there's a 4 and a 9. Now that couldn't be a 3 then, because that would need 8 and 9 touching it. So that's 1 or 2. And that is mirrored in one of those cells being 8 or 9. That's not an advance. Now, this can't be the 4-9 pair, you numpty, because the cage would add up to too much. So this is the 4-9 pair. And one of these other blue things is a, 2-cell things is a 6-1 pair. Interesting. That's the 4-9 pair. So this pair, if this had a 3, would have to have an 8 on it. And they would add up to 11, and that would break this cage as well. So that's the 3 in the row. And this is not 7. This is 8 or 9. That is now not 3, and that's not 7. And now there's an 8-9 pair, and that's not 9. And now, is this the tipping point? It would be too simple if it was. We've got 6, 7 in this circle and here, so that's not 3. That's 1 or 2. We've got a 1-2 pair here, so that's 3 or 4. And this isn't 7 as well. So now both of these 4-cell blue circles are 3s or 4s. And that means that 4-cell orange circles are 6s or 7s. I know I'm doing this a bit slowly, but I'm really struggling with how this works. They're 6s or 7s, and they don't touch 3s. So those are 1s or 2s. Please don't peter out at this point, logic chain. You're doing marvellously. That's a 6-7 pair in box thingy. So that one is 8 or 9. And the other orange digit in this box is also 8 or 9. We've had an 8-9 pair in this column. Still got to find space for a 4 in the column. That's not where to go. Now, come on, we've got that the 4-cell lines begin with quite internal digits. Oh, let's go back to this row. We know these two add up to 7 now. So they're a 1-6 pair to make the cage total work. And that's a 2 surrounded by a 7 and an 8. So that could be 4-9 opposite 1-6 in the 2 cells, or they could match up with the other ones. We don't know. We've got a 7-8 surrounding a 2. So one of these 3-cell things is a 3-2 surrounding an 8. Now that could be 3-2 here with 8 here, or 3-2 here with 8 here. One of these two is an 8. Where's the other 3-cell? It's this one. Ah, that 2 is looking at that digit. That's a 1. That doesn't make this a 6 necessarily. It does stop this being a 1, which removes one of the cells from here. I think 8 is not possible there. So one of these 4-cell blue-oranges ends in 8, 9, and the other one ends in 6 or 7. And that's these two places. One of them is from 1, 2, and one of them is from 3, 4. Neither of them can be a 4 though, because we've had 4, 9 there, and because 4 is accompanying 6 here. So neither of these blue at the end of a 4-cell line is a 4. So that's not 6, that's a 7. Now I can add up the cage and make that a 2. That means one of these two is definitely a 3 in this column. This is not a 3 on this line, it's a 1 or a 2. Oh, and one of these lines goes 7, 1 or 2, 8 or 9, 3 at the end. Don't know how to use that. At least things are happening a bit now. Now, this doesn't use 1 or 2. This is either a 3, 7 or a 4, 6 cage. And that is going to use the 7 between those. So this is not a 7. This is 8 or 9. Both of these center cells in the 3s are 8 and 9, which actually matches this 1, 2 pair perfectly. This one is 3 or 4 in this row. And that is the last cell of, well, it might match with that, in which case they're 3 or 7. But it might match with that, in which case, oh no, 7 is looking at that cell. That's a 6. But I still don't know if that means that is a 4. Well, one of those two is a 4 to match with this 6. So this is 1, 2, or 3. I mean, that's not exciting. Now, 6 is there. So 6 and 4 have gone. So this is the 4 in the row. And that's a 9. And that's an 8. And we're getting a bit of traction now. So one of these 3-cell lines ends in 1, 6. That's this one, probably. It's certainly not this one. So this one has to begin with the equivalent of that, which is 9 or 7. There's a 7, 8, 9 triple in the column. 2 has to be in one of those cells by Sudoku in the column, in the 3 columns. That's a 1, 2, 3 triple. So these are from Well, 4, 7, 8 and 9, but this one is seeing an 8, 9 pair in its column. This one's seeing an 8 in its column. That is seeing an 8 in its column, so that's even more powerful. So a 3-cell line goes 7, 2, 8 and must have an equivalent line that goes 3, 8, 2, which is this one, 3, 8, 2. So that's become a 7 since I got the 6 in the circle. That's now an 8 because it sees 7 and 9. So one of these 4-cell lines and the other polarity is going to go 3 something 2 something. It's probably this one, but it could be this one. Yeah, I don't know. That's not a 3 because we've got a 3, 7 pair in the box. So this is a 4, 5, 6 triple. That's been available for a long time. This is a 1, 9 pair. That's got to be the 9 because of the 1, 2 pair in the row. So that's a 1. That's 8 or 9, 7, 8 or 9. And then down here we've got 3, 4 and 6 to place. This one, okay, I can colour this, obviously. Now, let's look at the 2-cell lines. Those are the 2 that begin orange and become blue. So these 2 both begin blue and become orange, and now I can fill in their numbers. The low numbers first. 4, 9, 1, 6. Now, is that going to do some Sudoku for me? Well, that's not a 4. It really did very little. Oh yes, hang on, that 1 looks down here. 6 there. No, that's not. Oh, this can't be a 7 anymore. This is now an 8, 9 pair, very unsurprisingly. This is now a 1, 2 pair. And that's become a 3. And that's not a 9 or a 7. That's 4, that's 7. Now we're suddenly making progress. In the column, that's a 1. Look at this. 8. Imagine if I could fill in the rest of the grid without referring again to the indexing or indexing lines. That would be lovely. And it's very unlikely indeed. That's become a 1 though. That's not a 7. 2, 7, 4, 1. Now, come on, let's just keep going. This can't have 8 or 9 in it. So it's either 3, 7 or 4, 6. And that's a quad now. So this is 1 or 2, but it has to be a 1 in the column. That's 2. This is high. 6, 8 or 9. I am going to use these indexers, so we can match 4, 9 with a 6, 1 pair, that's this one, and we can match 1, 6 with a 9, 4 pair, that's down here. Lovely. That's 3 in the corner, proving its position like an absolute boss. That's a 9, that's a 3, this is not 3, 7, that is a 7. Ah, oh, lovely. I feel the sense of freedom when you finally get going in this puzzle is actually dramatic. Bit of Sudoku here. 3. Oh, look at the lovely Sudoku angle there. That's a 5. This is a 4, 8 pair. 8, 4. That's not an 8, so the 8 in the bottom is there. This is a 4 and a 9, which we will sort out. That's a 1 and a 3. That's a 6 and a 7. There seem to be a lot of numbers to sort out in rows 1 and 3, which will probably be done by solving this. Oh no, hang on, the 4, 9 is already done. That does 9, 5. That doesn't carry on, but don't worry. We've got, this is a naked 6 now. It sees everything else in the row and column. That's a 4. We get an 8 there. 8, 1, 6, 9, 4. We've got a... Okay. German whisper theory says this is 2 or 3. And that's a 1, 2, 3 triple in the row. So that's 5. That sorts out 6, 5, 6, 4. This is 3 or 7. And this is 2, 3 or 7. Okay, now I've got to use the 4-cell whispers again. So I've got 7, 2, 9, 3 and 7, 1, 8 something. So both of the others begin with a 3, then they go to a 9 or an 8. No, I'm on the wrong one there. It's, hang on, what have I done wrong? I was starting in the wrong place. I went the wrong way round on this one. So I've got a 3927. That's going to be matched by a 7183 line, which is not that one, it is this one. So that's a 3, and that's going to do it. Let me just check the other one. 3829 is going to be matched by 7281, and it already is. Okay, so that 3 is going to sort out the last few pairs here if I don't mistype the wrong digits. That's a 2, that's a 7. That 2 sorts out 1, 2, and 1, 3. Let's clear the colours, and we can fill in 9 and 7 here. And that is a tough puzzle of German Indeuxing. Very clever, Donatello 86. I enjoyed that a lot, but only once I got to the tipping point. Until then, it was a real strain. It's a very good puzzle, though, and I've enjoyed myself. Thank you for creating it, and thank you, everybody, for following the channel. Donatello was very kind about our solving of their previous puzzle, and hopefully we'll have enjoyed that one too. Thanks for watching. I hope to see you again soon on the channel. Bye for now.